Hi, I'm Tom, coming to you from the Sourdough Baking Academy Internationale of Cleveland, Ohio, also known as my kitchen. Thank you for selecting this video. In today's video, we will be continuing our quest to answer one of the most difficult questions for sourdough bakers, and that is, when is bulk fermentation done? If you're like me, when I started sourdough baking, this is one of the most frustrating and complicated aspects of sourdough baking. I still struggle with it today, and that is finding that point at the end of bulk fermentation where your dough is not underproofed and it's not overproofed, but it's perfectly, fully proofed. It is so challenging, and it takes a lot of experience to learn how to catch your dough right at that perfect point. And if you're an infrequent sourdough baker, this takes a long time. One week you bake a loaf and it's underproofed. You make a couple changes. The next week it's overproofed. You make a couple changes. The next week you use a different flour. The next week your starter isn't up to the exact same strength. And every time you're getting these different results, and it's very difficult to learn from the cues that the dough is giving you if you're an infrequent baker. So the purpose of today's video is to help you learn by showing you 4 specific examples of loaves going from underproofed to overproofed, and I'll show you the cues that you want to look for to determine when is bulk fermentation done. Now, in a prior video, I did a similar example where I baked 4 loaves of bread and I cut off bulk fermentation at roughly 30-minute intervals. And those were all perfectly acceptable loaves of bread, but you could clearly see the difference from slightly underproofed to slightly overproofed. In today's video, I'm going to be stretching that time out a little bit more to exaggerate the differences, really as a teaching mechanism, to show what a more underproofed loaf looks like, where I'll cut off one of the loaves early before I think it's done with bulk fermentation. I'll show you what an overproofed loaf looks like, where I'll let one of the loaves go a little bit longer than when I think it's done in bulk fermentation. And then I'll have 2 tries in the middle of those 2 loaves to try to get that cutoff point exactly right. So we'll vary the times by roughly 45 minutes between each one of the 4 loaves. Then we'll bake them up, we'll cut the loaves open, and we'll look at the crumb to assess the telltale signs of whether your loaves are underproofed, overproofed, or if you've really found that holy grail of a perfectly proofed loaf. So if you're interested in this topic of bulk fermentation, I have some other videos you might want to consider. First is a video called The Mystery of Bulk Fermentation. That's really where I go through all the details of everything that can impact the outcome of bulk fermentation. I highly recommend watching that video first. I have some other experimental videos. One is called Underproofed or Overproofed, A Tale of 4 Loaves, where I bake 4 loaves of bread and I change both the bulk fermentation and the final proofing time. And I have a new video that came out recently called Bulk Fermentation, Mastering Temperature and Time. In that video, I go through all the techniques, many of which I'll do in this video, where we control the dough temperature through controlling water temperature using a proofing chamber, assessing the impact of hand mixing on the dough, all the things that can affect the dough temperature. That's a set of skills that you really need to be able to master bulk fermentation. I recommend that as a follow-up video as well. And then in today's video, I'll be skipping over many of the front-end steps of this process. I won't show all the mixing of the dough or all the stretch and folds. I'm going to accelerate this towards the end of the bulk fermentation process so that I can really dive into the details of how do I assess when bulk fermentation is done. If you're interested in seeing all those prior steps, many of my other videos go through those in great detail. I follow the same recipe in every one of these videos. It's the tartine bread basic country loaf recipe from Chad Robertson's famous book, Tartine Bread. In some of my other videos, I go through this in tremendous detail. If you're a beginner, I recommend my 5-part series, The Sourdough Journey, Beginner Mistakes and Tips, where I go through the entire step-by-step process for beginners. And if you're an advanced sourdough baker, you might be interested in my 5-part series, Tartine Bread, The Art and Alchemy, where I go through the same steps but in much, much greater detail for intermediate to advanced sourdough bakers. So how do we know when bulk fermentation is done? Now, some people will tell you that this is an art that people develop by baking 100 loaves of bread. They'll tell you that they just learn to feel the dough, to listen to the dough. I've been baking sourdough bread for 11 months now. I've been listening really hard, and it hasn't told me when bulk fermentation is done yet, but I'm still listening. I think when people say that this is based on intuition and based on experience, that may be true, but many of the skills that you can use to determine the end of bulk fermentation are learnable, teachable skills that are based on science. So that's what we're going to start with here today. We're going to use science to try to get us 80 to 85% of the way to determining when bulk fermentation is done. And then that last 15% will be based on the experience of looking at all these variables together. And that's what I'll also try to teach you in this video today. So what are some of the things that I look at when we try to determine when bulk fermentation is done? The easy starting point is look at the recipe. And in this recipe, they give us 3 clues: time, temperature, and the percent rise. Those are the 3 things that you always want to look for first in a recipe. And if you're a beginner, I recommend selecting recipes that give you the recommended temperature, the recommended time, and the recommended percent rise in the dough, or at least 2 of those 3 variables. Otherwise, you'll be guessing the entire time. And there are a lot of recipes out there that do provide those variables, so keep looking for them. It's a much quicker way to learn when you're first starting as a beginner. So what does this recipe tell us about ending bulk fermentation? It gives us 3 important clues. 1 is the temperature. This recommends a very specific bulk fermentation temperature of 78 to 82 degrees Fahrenheit. That's 25.5 to 28 degrees Celsius. It recommends a bulk fermentation time of 3 to 4 hours, which is inextricably linked to the temperature. And it recommends a percent rise in the dough of 20 to 30%. If you follow those 3 aspects of the guidance in the recipe, you'll get very close to having a fully proofed, nicely proofed loaf of bread. And I've done that before. But there are a lot of other subtle variables that come into play that you also have to consider when you're looking at those 3 big variables that get you in the ballpark. And those variables are really based on more observation. So now let's talk about how we observe the dough after we've looked at the 3 time, temperature, and percent rise variables. The observations that I typically look at are, number 1, we want to do a window pane test. The window pane test is where we're going to stretch the dough up at the end of bulk fermentation and see if we can stretch that into a translucent membrane of dough. You want to be able to see daylight through the dough, and that indicates that you have enough gluten development in your dough. It's called the window pane test, and we'll do that in all these examples. The second thing that you want to look for is you want the dough to be domed up on top. If your dough has been in bulk fermentation and it's still looking pretty flat, that means that there's not enough aeration in the dough. So as the dough is starting to aerate and fill the gluten matrix with carbon dioxide, you'll see the dough start to dome on top. It's a very important indicator. The next thing that we look for are bubbles on the top. So again, as that carbon dioxide is pushing up through the dough, it'll actually push up through the top membrane of the dough, and you'll start to see some large bubbles forming on the top of the dough. Then you want to hold the bowl up. You should use a transparent bowl and look around the outside edges of the bowl and look for bubble activity around the edges, and you'll develop a feel for what that should look like over time in terms of the bulk fermentation activity. The carbon dioxide that's pushing itself out to the edges of the bowl will give you an idea of how much aeration is happening inside the bowl. The next thing that I do is something called the wobble test, where I'll basically shake the bowl of dough and start to get a feel for how the top of the dough should move when the aeration of the dough is sufficient. And then lastly, I do something that you don't see in many books or in many recipes, but it's called the smell test. Now the smell test is interesting, and this is why expert bakers say that it's based on intuition or listening to the dough. What they're actually doing is they're smelling the dough, and it's hard for them to articulate that because I've never actually heard anybody put this in a book or tell somebody that's how they know. But the smell of your dough will change as it's going through bulk fermentation. And I'll try to explain what I'm looking for in that smell test, where in the early stages of fermentation, you're smelling more of the raw flour smell, and in the late stages of fermentation, you're smelling something that's approaching what your starter would smell like, and you want to find the spot in the middle, and I'll try to describe that as best as I can. So those are the observational tests that we'll do. I'll do these on all 4 of the loaves as we're approaching the end of bulk fermentation to give you an idea of how I do these tests, what I'm looking for, what you could look for, and then we'll be able to compare the 4 loaves to each other, which is very helpful to do because it's often difficult to do this when you're baking one loaf once a week or once every 2 weeks. You don't really have a side-by-side comparison, so I'll try to do as much of the side-by-side comparison in this video as well. Now in this video, similar to all my videos, as I mentioned, we use the same recipe, Chad Robertson's Basic Country Loaf from the Tartine Bread book. Let me just give you the highlights of the recipe and the process because I'm going to skip forward and jump over some of these steps. This recipe is based on 1,000 grams of flour, and we're basically going to make 4 loaves. So these are essentially half-sized loaves. This recipe typically makes 2 nice-sized loaves out of that 1,000 grams of flour. I'll make 4 smaller ones. That 1,000 grams of flour is made up of 90% bread flour and 10% whole wheat flour. The brands that I'm using here today is I'm going to do a mix of the bread flour. So I do half of the bread flour, 45% of the total flour is the Central Milling Company Organic High Mountain High Gluten flour. This is about 13.5% protein. That's a higher protein flour. And then I mix the other 45% with the Organic Artisan Baker's Craft Plus flour from Central Milling Company. That gives me my 90% bread flour when I combine those 2 together. Then for my 10% whole wheat flour, today I'm using King Arthur Organic Whole Wheat Flour. So starting with that 1,000 grams of flour, we then use the baker's percentages to calculate 75% water, 20% leaven, and 2% salt. That's the basic recipe. It's a fairly standard recipe. A couple of unique things about the tartine recipe though, when you're looking at bulk fermentation, because when you cut off bulk fermentation, it's very specific to every recipe that you're following. It's based on the quantity and strength of your starter. It's based on the type of flour that you're using. So those can influence different recipes. In this recipe, those will be constant across all 4 of the loaves. But a few things that I just want to point out about this that are unique. One is that this recipe calls for a fairly low percent rise in the dough. It calls for a 20 to 30% increase in the height of the dough or the volume of the dough at the end of bulk fermentation. And the second thing that's unique and related to that is it's a fairly warm recommended bulk fermentation temperature of 78 degrees to 82 degrees Fahrenheit, which is 25.5 to 28 degrees Celsius. That relatively warm dough temperature is related to the relatively low percent rise in the dough because as you're doing the shaping, as you're doing the bench rest, as you're doing the final shaping, that dough is continuing to ferment at a fairly warm temperature. So that's the reason that this recipe calls for cutting it off a little bit early. You'll see that there are other recipes out there that have you bulk ferment your dough overnight at room temperature in the low 70s Fahrenheit or the low 20s Celsius, and they may call for a 50% rise in the dough or a doubling in the dough. Because it's at a lower temperature, you can get away with a little higher rise in the dough. When you're baking bread or bulk fermenting at higher temperatures, the dough can really run away from you very quickly. We are ready to mix the dough. I have prepared all the ingredients. Now I follow this recipe, I like to say by the book, but there actually have been 2 edits to the recipe after this book was published. So let me just clarify because they can impact the way that you count the timing. The first one is that there should be a 30-minute rest after adding the salt before the first stretch and fold. In the book, it's unclear whether there should be a rest. So the total bulk fermentation time that's recommended in the book starts with when you add the salt, but it omits that 30-minute rest. So we're going to add a 30-minute rest before the first stretch and fold to let the dough relax. And then the second thing that's just unclear in this book is the number of stretch and folds that are recommended. The book recommends 4, or it tells you to do 4 stretch and folds, and then it's ambiguous in terms of what happens after that. In some subsequent publications of the book, the recommendation is to do 6 rounds of stretch and folds with 30-minute breaks, so we're going to be doing that as well. So based on the book with those minor edits, here's the process that we follow. I'll mix the flour, the water, and the leaven. That's what the book calls the auto-lease or the ferment-to-lease process. We let that sit for 30 minutes. That's when our fermentation really starts, is as soon as the leaven hits the flour and water. Then we add the salt, we let that rest for 30 minutes. Then we'll do 6 rounds of stretches and folds with 30-minute intervals. Now in the interest of time, I'm gonna do all this off camera until we get up to the 5th stretch and fold. So I'll do the ferment-to-lease, add the salt, first 4 stretch and folds, then I'll divide the dough into 4 separate bowls, and I will travel slightly faster than the speed of light, and I'll come back on the 5th stretch and fold. That was quick. So 3 hours have passed in the last 5 seconds. Now during that time, I took copious notes, which is difficult to do when you're surfing the time-space continuum, but I did it. So here's what I've accomplished. I mixed the flour, the water, the leaven. I let that sit for 30 minutes. I added the salt. I let that sit for 30 minutes. I did 4 stretch and folds at 30-minute intervals on the mass of dough. Then I divided the dough into 4 individual bowls for the rest of the process. During this time, the dough has been right at 81 to 82 degrees Fahrenheit. That's the high end of the range of 78 to 82 or 25.5 to 28 degrees Celsius. So because we're pushing the high end of the temperature range, the recommended timing might be on the low end of the range. The recommended timing is 3.5 to 4.5 hours from the time we initially mix the dough. We're sitting at 3 hours right now. So let's do stretch and fold number 5 and see where we are with the dough. So stretch and fold number 5, 3 hours since we mixed the dough. We're into bulk fermentation. Now at the beginning of this video, I talked about all the ways that I measure to find out when bulk fermentation is done. At this point where we're still in the middle of the process, starting to approach the end of the process, I'm really looking at 3 variables: temperature, time, and percent rise. When we get really close to the end and we're trying to make the call, that's where I introduce those other criteria. But right now, let's look at temperature, time, and percent rise. So we're 3 hours in and the guidance is 3.5 to 4.5 hours. So I'm outside of the time window. The temperature is 78 to 82 degrees guidance. I'm sitting at 80 degrees Fahrenheit. That's 27 degrees Celsius. So I'm right in the middle of the temperature range, which is good. And then the percent rise should be a 20 to 30% rise. Now, let me pause for a minute, because when you measure the percent rise in your dough in bulk fermentation, it's incredibly important to use the right type of vessel. So when the recipe calls for a 20 to 30% rise in the dough, that means a 20 to 30% rise in volume, not in height. Because if I use a bowl like this, where it flares out at the top, a 20% change in height is a lot more than a 20% change in volume because it flares out on the bottom. So anytime you're measuring the percent rise, you want to use as close as possible to a straight-walled vessel like this. This is pretty close to straight. Or a vessel that has the milliliter markers on it. The milliliters measure volume. That's really the ideal way to measure this. So that's a pretty good vessel. This is a great one. I actually use these chemistry beakers sometimes. These are perfectly straight-walled vessels, so the height equals the volume, and it also has very fine-grained millimeter markers on it. So that's the most accurate type of vessel. Here's another one that I use. This one doesn't have straight sides, but it has my milliliter markers on it. When I'm bulk fermenting my full mass of dough and I'm going from 1,500 to 2,000 milliliters, this is certainly sufficient for measuring that. So you want something with either straight sides or the milliliter markers on it. These bowls are kind of somewhere in between. These are not really a straight-sided vessel. So what I do is I very carefully measure the milliliter volume on these. I put water into these and I put these markers on them. I do this all the time, so I'm kind of an expert at it. So I can tell exactly where we are. We're sitting right at 375 milliliters, which is where we are when I divided the dough. And even if I had divided the dough, as soon as I mixed it, 375 milliliters is kind of the starting point of this dough. It may have risen a little bit and then deflated a little bit because I divided this dough after the 4th stretch and fold. But let's just say that we're still at 0. So I'm not seeing much of a rise here. I'm seeing it starting to dome up in the middle. So I know there's some fermentation activity, but the actual percent rise, which I measure as the line right at the edge of where it's touching the bowl, is still at 375, which is my starting point. So my first three criteria: temperature, in the ballpark; time, not quite there yet, I'm at 3 hours, and the guidance is 3.5 to 4.5. Percent rise, not even close. So I don't want to do anything yet. I'm still in bulk fermentation. I want to keep these warm. I'm going to do the 5th stretch and fold on each one of these and put them back in the proofing chamber. Then we'll come back in 30 minutes for the 6th stretch and fold. Now, when you're doing the stretching and folding late in the process, you want to be careful that you're not manhandling or degassing the dough. So early on in the process, I really stretch this dough out a lot to really activate the gluten. But the closer that you get to the end, you want to be more gentle with it. And all I'm trying to do now is build some layers in the dough. I'm not trying to stretch it as much. So it's a little bit more about the folding than the stretching. When you're early in this process, those early stretch and folds are way more about the stretch than the fold. Now we're talking about the fold versus the stretch. While we're waiting for the next stretch and fold, let's take a look at this chart. This is from an experiment I did a couple of weeks ago where I was bulk fermenting loaves at different temperatures. This is a loaf at 82 degrees Fahrenheit, very similar to what we're doing here. And what I did is I plotted the percent rise in the dough every 30 minutes. So take a look at this chart. I'll put it up on the screen. What you can see here is that the loaf did almost nothing in the first 3 hours. And then at the 3.5 hour mark, it starts to increase, 4% increase, 7% increase. 4.5 hours, it's up to a 12% increase. And then look at that increase from 4.5 to 5 hours. What happens with bulk fermentation is you get this hockey stick effect, where it's very slow climb and then boom, at the end, it just shoots up and really can run away from you. So that's where bulk fermentation can be tricky, because you're watching the dough, it's not doing anything, you check it again, it's not doing anything. You kind of take your eye off the ball for a minute and the dough can run away from you, particularly at warm temperatures and at the end of bulk fermentation, because the fermentation process is exponential. When you get towards the end of the process, you have more yeast cells eating faster and faster and generating more carbon dioxide. So you get this inflection point at the end. It's a very important picture to keep in your mind as we're looking at what's happening in bulk fermentation. Okay, it's been 30 minutes. We are 3.5 hours into the process now since we initially mixed the dough. So this is the earliest possible that this dough could be ready based on the guidance. I'm going to do the 6th stretch and fold on loaves 2, 3, and 4, and then let's come back and look at number 1 and size this up and see if it's done with bulk fermentation. Okay, I've not done a stretch and fold here on loaf number 1. We're going to size this up. We're 3.5 hours in and see if this is done with bulk fermentation. First things I look at: temperature, time, percent rise. Temperature of the loaf, 79 degrees Fahrenheit. So this was running at 82, 81, 80, 79. On average, this is still above the average or the midpoint of 80 degrees Fahrenheit or 27 degrees Celsius. So this is on the high side of the temperature over the whole full 3.5 hour range. When I look at the time, 3.5 hours is the low end of the possible fermentation range given by the book. We're right at 3.5 hours. The percent rise should be at 20%, and I'm still sitting right where I started at 375 milliliters. This really doesn't look like it's risen at all around the edges, but now let's proceed to our next round of criteria. This loaf is domed up in the middle. There's clearly fermentation activity happening in here, and I can see it doming up and it's getting ready to pull itself up in the bowl, but it hasn't quite done it yet. The second thing I look for is, are there large bubbles on the top? I don't see any large bubbles, but I see a few small bubbles here and there on the top of the dough, so it's getting close. I want to look at the sides of the bowl and say, do I see any bubble activity on the sides of the bowl? I see a few bubbles here and there, a few small ones, but not very much and not very big. Then we can do the window pane test to see if we have sufficient gluten development. So the window pane, you basically grab the dough, stretch it up out of the bowl, and you want to get a super thin membrane. That's a beautiful window pane right there. I mean, I can see daylight through that. That's the definition of a window pane. not ripping. So I have great gluten development in this dough, but it just hasn't risen. I can also shake it, and I'm getting some wobble when I do my wobble test. So there's some aeration in the dough. And then when I smell it, the continuum of the smell that you're looking for is something like a bag of flour or just flour and water is on the under fermented side. And when it starts to smell like your starter, it's on the over fermented side. This is still kind of left of center, leaning towards more of a floury smell than a starter smell. So the smell tells me it's still not quite there. So now this is where, as a beginner or even as an experienced sourdough baker, you start to move into something between wishful thinking and lying to yourself. So here's how this goes. I say, is this done? The guy in the video said you got to check 3 things: temperature, time, percent rise. Temperature is in the ballpark, 80 degrees Fahrenheit, 79 degrees Fahrenheit. I'm good. That's 1 out of 3. Second thing is time. The book says 3.5 hours from when you mix the dough. It's 3.5 hours since we started. I got 2 out of 3. The third one is the percent rise. It didn't quite rise 20% yet, but it really wants to. I can tell it's getting ready to rise. Maybe it would have risen 20% if I hadn't divided it up into separate bowls. So I'm going to go with maybe 2 out of 3 ain't bad. Unfortunately, that works if you're making meatloaf, but not when you're making bread. You really need all 3 of those criteria, but you still want to push forward and say, I'm moving on. I got 2 out of 3. Now let's look at the other criteria. I see a few bubbles on the top. I see one right there. I see a few bubbles on the side. I shake it. It looks kind of shaky. I did the window pane test. I have a beautiful window pane. I think this is done. So this is the mistake you make. You're not quite there with all the criteria, but you're close. We're going to bake this up and see what happens when you cut it off early. So I've created this chart for each one of the loaves as we go forward. And what I've done is I show the 9 evaluation criteria on these 9 slider bars. And then I show the indications from left to right of what an underproofed loaf typically looks like up to an overproofed loaf, with the preferred range being that box in the center. Then for each one of the criteria, you'll see those red, yellow, and green triangles indicating where each one of these indicators lies for this loaf. And we'll do this for each of the 4 loaves. You can pause here if you want to review this in more detail, but you can see clearly for this loaf, many of the indicators are still left of center and outside of that desired proofing range. So this would tell us that this loaf would likely be underproofed. So loaf number 1, against my better judgment, I'm calling it officially done with bulk fermentation because we're going to see what happens when you do this. Very common. This happens all the time. I still do it occasionally. You're in a rush. You got to move on. You don't have all day to stand around watching your dough. We're going to move along. So I'm going to take this dough. Now, normally in the process at this point, I would dump this out onto an unfloured work surface. I would divide a larger mass of dough. I would pre-shape this into a round. I would let it sit for 30 minutes, and then I would do a final shaping. That's exactly per the book. So I'm going to get close to what the book does in terms of fermentation, but not all those steps. So here's what I'm going to do. With these loaves, I'm not going to do any shaping. And the reason is because when you do pre-shaping and final shaping, you can introduce a lot of irregularities into the crumb, and it's very difficult then to diagnose when you cut the loaves open what was caused by underproofing or overproofing versus poor shaping. So I've done this in some of my other videos. We're just going to bake up this slab of dough without doing pre-shaping or final shaping. And it's just like putting an X-ray machine on this dough and only looking at the impact of bulk fermentation, completely excluding any of the impact of shaping. So now, because I already divided these into 4 separate loaves, that's part of what the pre-shaping process is all about. The reason you have to do pre-shaping is usually because you're making a large mass of dough that can serve up 2 to 4 loaves. I've already divided it. So in some ways, pre-shaping is really not required when you've already divided your dough. So I've taken that out onto my work surface. And I'm literally just going to put this in the shaping basket. just like that. So I have a slab of dough in my shaping basket. One other thing I like to do is I like to shake it and see how the dough is moving. And that's not super firm dough. I mean, that dough is somewhat loose. The difference between firm and loose dough is that firm dough, when you put it in the shaping basket, the whole loaf will rock back and forth like this. Looser dough almost looks like the top of the dough is wiggling and the bottom is not. So that dough actually is getting there. It looks pretty aerated. So now we're going to let this rest for 30 minutes because normally after pre-shaping, there's a 30-minute bench rest at room temperature and then a final shaping. So we want to give it that extra 30 minutes to ferment because that's part of the recipe. And the yeast doesn't know bulk fermentation is done. I mean, I officially called the end of it. I can tell it, stop fermenting, bulk fermentation is done. The yeast doesn't listen to me. The yeast only knows the temperature. As long as the temperature is favorable, the yeast keeps fermenting. Very important to understand that point. And even when the loaf goes into the refrigerator, take a look at this chart. What I did was I put a loaf of dough into the refrigerator and I put a continuous read thermometer into it and I tracked the temperature in the refrigerator. This one went into the fridge at 78 degrees Fahrenheit, 26 degrees Celsius. Look what happens in the refrigerator. It took 3 hours, almost 3.5 hours for the temperature to get down to 50 degrees Fahrenheit or 10 degrees Celsius. During that time, the loaf is still fermenting. So even though this experiment is talking about when do we cut off bulk fermentation, that's just an arbitrary cutoff point because it's sitting on the countertop, it's still fermenting right before my eyes. The yeast doesn't know bulk fermentation is done, it's still fermenting away. Then when I put it in the refrigerator, as that temperature starts to cool, the yeast will slow down. That's why it's called a cold retard. Retard means slow down, but the fermentation doesn't stop until the yeast gets down to 37 degrees Fahrenheit or 3 degrees Celsius, which takes 10 hours in this example. So we're talking about cutting off a component of fermentation at this point, the arbitrary end of bulk fermentation. This dough is still fermenting until the moment we bake it. So 30 minutes on the countertop at room temperature, then we're not going to do final shaping. It'll just go into the fridge overnight for about 12 hours and then we'll bake it up tomorrow. And now that we've set the baseline with loaf number 1, what I'll be doing with loaf 2, 3, and 4 is I'm just going to cut those off at 45-minute intervals, just arbitrarily based on time. So we're going to see the impact of 45-minute intervals of extending bulk fermentation from the point where we cut off loaf number 1. Okay, it's been 45 minutes longer than when we pulled loaf number 1 out of bulk fermentation. So loaf number 2 has been going for 4 hours and 15 minutes since we combined the ingredients. That's against the target range of 3.5 to 4.5 hours of fermentation. So we're nearing the end of the typical range. So this one, in terms of time, is looking good. In terms of temperature, we want to be between 78 and 82 degrees Fahrenheit. We're sitting at 80 degrees Fahrenheit, 27 degrees Celsius. That's right at the midpoint of the temperature range. So I'm good on time, I'm good on temperature. Now I'm looking for my 20 to 30% rise in the dough. When I look at it against my marker on the side of the bowl, this is up maybe 10%. So I'm still not quite getting the full percent rise that's called for in these 3 criteria. So it still technically is going to look underproofed from a bulk fermentation perspective. Let's look at our other criteria. Am I seeing bubbles on the top? Not really. I'm seeing more aeration on the top. I'm seeing a higher dome on the top of this than on loaf number 1, but I'm still not seeing bubbles inflating on the top. If I shake this, the aeration looks pretty good. I mean, this is really wobbling up against the sides of the bowl. So the dough looks somewhat aerated when I shake it. Now let's do the window pane test to check our gluten development. Again, like loaf number 1, this one's ripping a little bit, but I'm trying to stretch it a little further. Really superb gluten development there. So plenty of gluten development. If I look for bubbles on the side of the bowl, I see a few more bubbles than I saw in loaf number 1, but still not what I would call vigorous bubble activity around the edges of the bowl. So this one still looks slightly under based on all the criteria that we have to evaluate this. For loaf number 2, here are the indicators in the 9 criteria. You can see that a few of these have moved into that desired range in the middle of the chart, but many of the indicators are still to the left of center, which indicates that this loaf is improving, but it's still not showing all the desired indicators, and this may still be an underproofed loaf. But I'm still going to pull this one because we're trying to see this continuum of what these loaves look like as they proof a little bit longer and longer. So similarly, no pre-shaping and no final shaping. I'm going to try to take this out of the bowl a little bit more carefully than I did loaf number 1. And we go right into the shaping basket. That's it. Then I shake that. Again, that dough's moving. I mean, it looks like it has pretty good aeration based on shaking it. I'm also leveling it out in the pan a little bit because I'm not doing any shaping. Let me do the smell test. That still smells a little more like flour than like starter. So again, that indicates that it's maybe slightly under versus over. Now this will sit here on the countertop for 30 minutes, which would be the typical bench rest. Then it goes into the refrigerator for a 12-hour overnight cold retard. Hi, I'm Tom from the future, coming back from the end of this video to tell you what actually happens. What happens at the end of this video is all 4 of these loaves are underproofed. And the reason for that, which was not evident until the end, is because I used a weak starter to create this bread. How did I create a weak starter? I just created a brand new starter 2 weeks ago, 2.5 weeks ago, and I actually baked some pretty good bread with this. So I know that this starter has the ability to make great loaves, but this starter was past its peak when I used it to create my leaven. When you create your leaven, you always want to have your starter as close to peak as possible, especially if it's a brand new starter. My starter was past its peak, so I took a weak starter to create my leaven, and then just to make my life more difficult, I cut my leaven development shorter than I knew I should have to try to get started with making of the video. I was trying to stick to a schedule. My starter wasn't cooperating, so I just forged ahead anyways. So I had a new starter past its peak, and I cut my leaven development short. So right from the start, I went into this process with a weak leaven. And here's what I'm here to tell you. There's no way you can compensate for a weak leaven. There's nothing you can do in bulk fermentation to remedy that. I tried everything. You'll see it in this video. It just doesn't work. If you don't have enough gas in the tank, if the yeast doesn't have enough energy going into the recipe, there's nothing you can do to fix it. So this is a great video because it shows the telltale signs of what happens when you have a weak starter or a weak leaven. But more importantly, this video shows you the tricks that the baker's mind will play on them, and you start to ignore what your eyes are seeing. You'll see the stories that I start to tell myself, the way that I try to rationalize how everything is still going great, even though there are telltale signs throughout this entire video that this wasn't going to have a happy ending, and I ignored them all along the way, even as an experienced baker. That's the most instructive part of this video. I hope you find that helpful. It's been 45 minutes since we cut off loaf number 2, so loaf number 3, I'm doing each one of these now at 45-minute intervals. So let's see where we are. When I look at our percent rise on this one, we are just at 20%, just barely 20%. The temperature, 81 degrees Fahrenheit, 27 degrees Celsius, right where we want to be. And the time is 5 hours from when we initially mixed the dough. The guidance said we should be between 3.5 and 4.5 hours. Now let's look at the other variables. Is the dough domed up on top? Absolutely. This one is really highly domed on top. Do we see large bubbles on the top? Yes, there's actually a huge bubble right there on the top that I see. So we're getting that aeration all the way up to the top of the dough. Are we seeing bubbles around the side? Still a little bit, not quite as much activity around the side as I normally would see. And when I shake the loaf, again, very loose. So that dough is aerated and loose. It looks fermented, just not giving us the percent rise that I would have expected as quickly as I would have expected, but this is definitely in the ballpark of what I would expect for a loaf to look like when it's done. Now let me do the smell test. Now this one is just starting to give a hint of more of that vinegary smell that you get out of your starter, but this still smells pretty much like flour. But I'm absolutely smelling the vinegar smell coming out. So we're starting to cross over that point now where all these criteria are saying that this one might be done. Still maybe early, but it's really close. Let's get this into the shaping basket. Now this dough is incredibly soft and sticky. I'm a little surprised. That caught me by surprise. Now, the way that dough came out of the bowl, this actually feels more like it's pushing overproofing than underproofing. So we've really turned the corner here between Loaf 2 and Loaf 3, where Loaf 2 was still really firm coming out of the bowl, and this is really soft. So let me shake this. You can see how wobbly that dough is. A lot of movement, very sticky along the sides here, almost liquefying. So this is starting to look like what a more overproofed loaf would look like, at least just based on the shape of the dough. Let's not forget the window pane. Now this is tearing much more quickly. That's a really nice window pane, but this is tearing more quickly, which implies that I'm starting to lose a little bit of my gluten structure here, which is what happens when you start to go past that perfect proofing point. So that's another indication that this one might be going too far. So this will be interesting to see how these shape up. For loaf number 3, you can see many of the indicators are starting to move into that center box, into the desired range. A few of them are still slightly left of center, those 3 yellow triangles. And somewhat concerning is we're now seeing the timing move into the overproofing range, and the window pane is getting pretty close to showing that the dough is also weakening. So we're starting to see some indications or risks of overproofing as well. This will bench rest for 30 minutes and then go into the refrigerator for the overnight cold retard. Loaf number 4. So this is 5 hours and 45 minutes after we mixed the dough. This is 45 minutes longer than loaf number 3. Let's see what our temperature is. 82 degrees Fahrenheit, so we're a little bit on the high end of the range. All these loaves were at 80, 81, 82 through the whole process, right where we want to be. The time, this is well outside the recommended range of time. So the recommendation is 3.5 to 4.5 hours from the time you mix the dough. We're at 5 hours and 45 minutes, so hour and 15 minutes past the recommended time. And the percent rise, interestingly, is maybe 10% maximum. So this is less than loaf number 3. This is a bad sign. This is an interesting example to show here because this is what's known as the stall. The stall is where you're waiting for the dough to rise, and it actually rose and then it started to deflate. And the longer you wait, the worse it gets. This is a bad scene. This is like in an aircraft when you have a stall. The thing that happens after the stall is the death spiral, which is what's happening here. The longer I wait for this to rise, the worse it's going to get. This is heading towards overproofing. Now what happened here? Why did this happen? Because in your sourdough starter, you have 2 microbes. You have the yeast and you have the lactic acid bacteria. The yeast is trying to aerate the gluten matrix, and the lactic acid bacteria is trying to eat the gluten matrix. And what's happening here is the lactic acid bacteria is working faster than the yeast. Now this can be caused by a weak starter. And one of the things I failed to mention in this video is that the starter I'm using here is a brand new starter that I created about 2 weeks ago. Part of the reason I wanted to do this experiment because this was a good test for me because I wasn't familiar with the starter. I'm using some different flours than I normally use. So I really have to be on my toes to watch what's happening here. And what I'm seeing here is my starter ran out of gas. The starter had a higher population of lactic acid bacteria than it had of yeast. The lactic acid bacteria outran the yeast and it outate the yeast. So it's consuming the gluten that the yeast is trying to fill with carbon dioxide. So this is a bad scene. So let's proceed with the test so you can see what happens here. So I'm in the temperature range. I'm on the high end of the temperature range, which is a little risky. I'm well over the time, which implies I'm at risk of overproofing. My dough has not risen, which is a bad indicator. I look for the doming on top. This dome is lower than the dome on loaves 1, 2, and 3, so this dough is collapsing. I look for bubbles on the top. I see 1 or 2 small bubbles around the edges, but I'm not seeing that big puffed up dome or big bubbles in the middle. I shake the dough. This looks about the same as the others when I shake it, maybe a little bit looser. When I look at how that's bouncing off the sides of the bowl, that's a little bit looser, more liquefied dough. And then let's pull the window pane. This dough is super thin. I can barely grab it. And as I pull my window pane, I'm still getting a decent window pane here. And there it rips, similar to loaf number 3. That's not horrible. So I still have some decent gluten structure here. This is not completely gone yet, but it's heading that direction, and it's just running out of gas in terms of the yeast production. Then I smell it. Definitely smells a little further along than the prior one, slightly more vinegary smell for sure than loaf number 3, but not completely gone. This isn't a bowl of starter yet, but it's kind of pushing that direction. So let me get this out of the bowl. Now this is going to be incredibly loose dough. So this is really going to take some skill to get this into that shaping basket without shaping it. I'm just going to try to lift it and move it. That's called the flop. This dough is incredibly wet, incredibly loose. Now there you can see when I shake this, this looks very different than the other loaves. This is a super loose, super wet looking dough, which again indicates that it's losing its structure and pushing towards overproofing. I'm surprised that the window pane held up. That's a good sign because that means that there's still some gluten in this loaf, but it's just headed downhill fast. Now for loaf number 4, this chart is an anomaly. It's very uncommon to see this, where we're seeing both indications of underproofing in terms of aeration of the dough and overproofing in terms of the gluten deterioration in the dough. So this is really an odd occurrence. Let me put this on the countertop for 30 minutes. We'll let it continue fermenting, and then it'll go into the fridge for the overnight cold retard. We'll bake all these up in the morning and see how the crumb looks on the inside. It's the morning of day 2, and it is time to bake the loaves. So the 4 loaves have been in the refrigerator overnight for the cold retard. My refrigerator temperature is about 37 degrees Fahrenheit or 3 degrees Celsius. The loaves have each been in the refrigerator for about 12 hours. I put them into the refrigerator at 45-minute intervals, and I will take them out of the refrigerator at 45-minute intervals to go into the oven. I'm preheating my oven to 500 degrees Fahrenheit. That's 260 degrees Celsius with my Dutch oven in the oven preheating. I put the loaves into the Dutch oven. I put the lid on and reduce the temperature to 450 degrees Fahrenheit. That's 232 degrees Celsius. Bake them for 20 minutes with the lid on. I remove the lid and bake them for about 15 more minutes at 450 degrees Fahrenheit, 232 Celsius, for a total of about 35 to 37 minutes. These are relatively small loaves, 250 gram flour weight loaves. They usually bake up in that amount of time. So I'll just simply score and bake these loaves. Then I'll do this off camera. We'll come back, and after the loaves have baked and cooled, we will inspect the loaves and see if we can tell what the impact is on the crumb of the loaves based on the differences in the bulk fermentation time. And as a reminder, I don't do any additional shaping of these loaves. I simply dump the dough out onto parchment paper and bake them as is. I'll simply score them once. I also take them directly from the refrigerator and put them into the oven. There's no additional proofing time here. I'm not allowing them to come up to room temperature. So all the proofing that we saw happened yesterday, and then that slow decline in the refrigerator, which should have been exactly the same for all 4 of the loaves. The 4 loaves have baked and cooled. Let's take a look. All 4 of these loaves baked for about 37 to 38 minutes. They all baked up very similarly. Let's take a look at each one. Loaf number 1, this was the loaf that we pulled the earliest at 3.5 hours out of bulk fermentation. That was the low end of the guidance, 80 degrees Fahrenheit, which was within the range, but there was 0% rise in the dough. And you can see what happens here. That is a sad, underproofed loaf. Really no rise in the dough when we baked it. There was no rise in the dough when it fermented. It also baked up with this very blonde color. As you can see, that's typical of an underproofed loaf because the longer you ferment the loaf, the more sugars that come to the surface. So you'll see the darkening of the loaves as they fully proof. That one looks like a classic underproofing. Loaf number 2, interestingly, this was the exact same dough as loaf number 1, and 45 minutes later, there's the loaf that we get. A very nice looking loaf. Now this is a little bit pyramidal in shape. If you look at the sides of that, the way that the sides angle up almost in a triangular angle, that can also be a sign of underproofing. And when you get more of a dome or a belly in the middle, that can imply that there was some unfermented yeast in there when it went into the oven, but that's not a bad looking loaf. And I'll also remind you that none of these loaves had any shaping. We didn't do pre-shaping, we didn't do final shaping. So what you're really seeing here is just the impact of the structure coming out of bulk fermentation. That's a pretty good looking loaf with no shaping. Now loaf number 3, let's look at this one first from the top down. And what you see here between loaf number 2 and loaf number 3 is loaf number 3 now is starting to relax. So this looks a little more oval in shape, and it looks a little wider around the midsection here. So loaf number 3, we got a decent ear, decent height, but you can see how the shoulders are rounded and much more sloping shoulders than what we saw in loaf number 2, which was more angular and pyramidal. That implies that there's more proofing here in loaf number 3, and that this is starting to move up the continuum towards possibly overproofing. And then loaf number 4 is a real surprise, where this one also spread out, so it's a little bit wider loaf here, a little bit rounder when you look at it from the top down. But look at the height and the oven spring and the ear that we got on that loaf. I mean, that's really a surprisingly good looking loaf. So let me recap the times and the percent rise just for the record. As I said, loaf number 1, 3.5 hours of fermentation, 80 degrees Fahrenheit, 27 degrees Celsius, 0% rise in the dough when we put this into the shaping basket. That's what you would expect. Loaf number 2, this went 45 minutes longer, 4 hours and 15 minutes of fermentation, roughly 80 degrees Fahrenheit, 27 degrees Celsius. This one rose about 10% before we shaped it. This one might still be a touch on the underproof side, I'm not sure, but this was starting to be within that range of the recommended time of 3.5 to 4.5 hours. This was 4 hours and 15 minutes. So this is where the guidance started to line up, but we didn't see the 20% rise that we were expecting. We were only at 10%. Loaf number 3, this took 5 hours of total time, so 45 minutes longer than loaf number 2. This one looks like it fermented more. It did hit that 20% rise. That's a recommended rise. It was at 80 degrees Fahrenheit, roughly 27 degrees Celsius. So just based on the statistics, this loaf should be the closest to being I'd say fully proofed loaf. But looking at it, it looks like it might have gone a little bit past where we want it because it's a pretty relaxed structure. I'm not seeing as much of a tight structure as I would expect. And then loaf number 4, the real surprise, this was an incredibly slack, wet, loose loaf, 5 hours and 45 minutes, so well past the recommended time. This one maintained pretty good shape and structure. So when we compare these loaves to each other, there are a few things that you want to consider. Loaf number 1 and loaf number 2, now these were really significantly different. The only difference was 45 minutes of proofing. I mean, this really shows the impact of time. I didn't do anything between these 2 loaves because we didn't do shaping. They weren't shaped differently. All I did was let this loaf sit for 45 minutes longer than this loaf. And that's a pretty extraordinary difference. So when I look at loaf 1, that's what I call lost potential, because Loaf 1 and Loaf 2 were twins. These came from the exact same batch of dough. In fact, all these did, but I'm just comparing these two. That's just a great example of what difference 45 minutes makes in terms of how the loaf looks, and we haven't even cut this open yet. Loaf number 3 and loaf number 4, the interesting thing about these are further along in the proofing, 5 hours on loaf number 3, 5 hours and 45 minutes on loaf number 4, and loaf number 4 surprisingly has better structure than loaf number 3. So this was a little bit of a mystery to me when I saw this. But what I remembered, if you go back and look at the videotape, is that when I took the dough out of the bowl in loaf number 3, I was surprised at how loose and slack that dough was. And the dough kind of fell apart in my hand, and I dumped it into the shaping basket. So this loaf lost a little bit of its inherent structure just in that transfer from the bowl to the basket. Loaf number 4, I was more aware of how loose that dough was, and I was very careful when I lifted that out of the bowl to keep as much of the shape as possible, and I flopped that into the basket, still maintaining a lot of its shape. That little subtle difference in the way that I moved the dough from the bowl to the shaping basket made the difference in those two loaves. That's pretty amazing. Now, if you're interested in learning more about this concept, I have a video called The Impact of Bulk Fermentation on Open Crumb. That's in my Open Crumb series, where I go through and I bake up different loaves, and in bulk fermentation, I show how the handling of the dough in bulk fermentation can significantly impact the crumb of the loaf, with no pre-shaping and no final shaping. That is really evident here just looking at these two loaves. Loaf number 4, even though this proofed longer, it looked like a much more slack loaf. Because of that careful handling, I was able to maintain the structure that I had built during bulk fermentation when I got it into the basket. On loaf number 4, I lost that structure just because of the way I handled it. Then lastly, on loaf number 4, one other thing I notice here is if you look at this loaf, we had an explosion here on the top of the loaf. That's significant because that implies that the gluten structure was starting to deteriorate on this loaf. Even though I did this huge scoring and it opened up beautifully on the scoring and on the ear, it also pushed up through and tore through that loaf on the top. You'll also see that when you start to push towards overproofed loaves because the gluten structure starts to weaken. But the outside of the loaf only tells part of the story. Let's cut these open and see the rest of the story. So loaf number 1, based on everything I know about this, we cut it off early. We didn't see the percent rise in the dough. It didn't inflate in the oven. It didn't open up. It's baked up blonde. This looks like an underproofed loaf to me. Let's see what the crumb tells us. And there you have it. That is a classic underproofed loaf. You have this very dense crumb, around probably 80% of the loaf. And then where the crumb did open up, you see these tunnels that are actually penetrating through the loaf. So I can stick this chopstick down in there. This is called tunneling, where this is unfermented or underfermented yeast that when you put it into the oven and you get that last gasp of fermentation as the temperature starts to rise, small clumps of yeast kind of go crazy because they haven't expended all their energy yet. And you get these big explosions of what's called tunneling in the crumb. That's a very underproofed loaf, textbook picture right there. Loaf number 2. So this fermented for 45 minutes longer, 4 hours and 15 minutes total time from when we started mixing the dough, but we only saw a 10% rise in the dough before we took it out of the bowl into the basket. So this one may be on the underproofed side as well. Definitely underproofed as well. Here you can see, some people might call this a fool's crumb. You see this giant tunneling, these big open cells on the top, very super dense crumb along the bottom. This dough is gummy. It actually gummed up on my knife when I cut through it. So this loaf is underproofed. So let's recap the vital statistics of this loaf. This one fermented for 4 hours and 15 minutes against our range of 3.5 to 4.5 hours. So it was within the range. The temperature was roughly 80 degrees Fahrenheit, which was where we wanted to be. but the percent rise in the dough was only 10%. So the percent rise told us this wasn't ready, but we went with it anyways, and you get an underproofed loaf. Another classic case of underproofing, not as bad as loaf number 1, because this actually inflated quite a bit. I mean, when you look at that loaf on the outside, this is the type of loaf I call false hope, where you think that's going to work out okay, but I could tell from that pyramidal shape, from the bulge or the belly on the top, that you had this big gas bubble in here. Very dense crumb along the bottom, gas bubbles on the top. Classic underproofing, loaf number 2. "45 minutes later, we're on to loaf number 3. Now loaf number 3 actually did hit the 20% rise mark. The temperature was 80 degrees Fahrenheit, 27 degrees Celsius, and the time took 5 hours versus the recommended range of 3.5 to 4.5 hours. Sometimes you just have to let the time take what it takes. So this is really probably the best loaf in terms of trying to hit the marks of what we were looking for in terms of temperature, time, and the percent rise in the dough. Now that's a pretty dense crumb. I'm a little surprised here that this also looks slightly underproofed to me. This one's a tough call. So we didn't get the tunneling or the big gas bubbles that we saw in the other one, but we still just have a super dense crumb where you can see that this crumb just did not open up at all. And this is a pretty good looking loaf. The shoulders, as I said, started to relax a little bit, so the gluten is getting a little bit stretched out here, where I was inclined to think this might be even pushing overproofing. We might have to cut deeper into this one to know for sure. That one's really a tough call. Loaf number 3. And then loaf number 4, this one went 5 hours and 45 minutes, so well outside that recommended high end of 4.5 hours of recommended bulk fermentation time. The temperature was, again, at the target, 80, 81 degrees Fahrenheit, 27 degrees Celsius. But the percent rise in this, if you recall, it seemed like it rose and then it fell. So this was really back down to 0% rise, and I could feel the gluten deteriorating when I was taking this out of the bowl. So let's see what this one looks like. This is really a mystery to me. Now that loaf is better looking, but still underproofed. So this is a bit of a surprise. All 4 of these loaves are underproofed, even at 5 hours and 45 minutes. So here I can tell this is underproofed because I have the dense crumb, very dense unfermented dough right there in the center, and then the classic tunneling that you see here around the top. So despite my optimism, when I saw how these loaves looked on the outside, particularly loaf number 4 looked pretty good, all 4 of these loaves underproofed. Now how do we know that? We know that for certain because the dough didn't rise. I mean, only one of these, loaf number 3, just barely hit the 20% rise mark. The rest of these loaves just didn't have enough gas. They just didn't, the dough just didn't rise. So what's the cause of this? The most typical cause, and that actually likely happened here, is when you have a weak starter. Now, one of the things that I didn't mention very early in the video, but I mentioned midway through, part of the reason I did this experiment is because I have a brand new starter that I just built 2 weeks ago. So I basically have a 2-week-old starter. I've baked some decent loaves with that. These didn't work out. So that starter just didn't have the energy that was needed to rise this dough. So this is a classic case of what your loaves look like with a weak starter, where no matter how much time you give this and how much attention you pay to hitting the proper temperature, and we did all the stretch and folds properly, we had the window pane, the weak starter just can't compensate. There just wasn't enough gas in the tank. And then as we got into these later loaves where you just want to wait and wait and wait, you start to get into this death spiral where you're waiting for the dough to rise, but at the same time, the gluten structure is starting to break down. Because in your starter, or in your leaven, there are 2 microbes. There's the yeast, which is trying to fill the gluten matrix, and the lactic acid bacteria releases something called the protease enzyme that eats the gluten matrix. That is the constant battle with trying to proof a loaf, and the fact that we just didn't have enough gas in the tank. We didn't have enough yeast, enough powerful yeast in this starter to rise the loaf. We waited and waited and waited, and as we get further down through the bulk fermentation time, the protease enzyme starts to show up and it starts to break down the gluten structure, which you could see through this tearing in the top here. I can tell just by the shape of the loaf that if we had let this go much longer, the yeast was out of gas and the protease enzyme would have eaten its lunch. It would have just started to deteriorate the gluten. So basically I showed an example here of how to underproof a loaf, or how to underproof 4 loaves. And if you actually go back and watch the videotape, I did exactly what I said beginners do, and I still do it myself, is your mind plays tricks on you. Your eyes play tricks on you, and you start lying to yourself and telling yourself stories about why you're not seeing bubbles on the top, why you're not seeing bubbles on the side, why the dough maybe it didn't rise yet. The dough doesn't lie. It really doesn't. It was telling me all along that these loaves were looking underproofed. They felt overproofed. Now, and that's this issue that you run into with a weak starter, where the dough is looking like it's underproofing, but it's feeling like it's overproofing because the lactic acid bacteria releases the protease enzyme and it starts to eat the loaf before the yeast can fill the gluten matrix. This is the classic case. So what is the moral of the story? The moral of the story is that if you have a weak starter, there's nothing you can do to compensate for that. No amount of time, no amount of temperature, no amount of anything that you can do as the baker in bulk fermentation can compensate for a weak starter. I just proved it right here. So this starter, as I mentioned, it's 2 weeks old. I've actually baked some decent loaves with this. So what happens here is, I would say a new starter is inconsistent, and I can even tell this when I mix it from day to day, that if I catch this starter exactly at its peak and I put that into my leaven, I actually baked some pretty good loaves with this starter in some of my prior videos actually. But when I baked this loaf yesterday, these loaves yesterday, the starter was a little past its peak when I created the leaven. So I didn't have the full charge of yeast going into my leaven. And then my leaven wasn't quite fully developed when I started the loaves. I pushed my timing a little bit. So I basically took a weak starter, I put it into the leaven, and the worst thing you can do with a weak starter is not give it time to fully develop. So I basically created a double whammy here where I did a weak starter and a short leaven build, went into these loaves with basically a weak leaven, and that's what caused this result. So we don't want to pass up another opportunity for learning. So in the interest of science and education, I've now sliced all of these underproofed loaves and I lay them out in this autopsy photo that I would contribute to the International Encyclopedia of Underproofed Loaves. Here we go. I have all varieties. Loaf number 1, this is our 3.5 hour loaf. This is just a gummy, flat, underproofed loaf. I mean, this is like a beginner loaf with a brand new starter, cut off bulk fermentation too early. That's kind of a mess, number 1. Number 2, this is a more common, this is sometimes called fool's crumb, but this is really gigantic, cavernous fool's crumb, where you just have a lot of under-fermented yeast still in the dough, and when it hits that oven temperature, you get these explosions of these tunnels, and usually these big vertical, cavernous, cathedral-like tunnels in here. There's a perfectly round-shaped one, very interesting. This is classic underproofing, and this, when we saw the loaf, is what I call false hope, because sometimes these loaves look pretty good. You get a lot of oven spring with that big belly or the big bulge on the top. The big bulge is just air caused by those caverns, so that's what you'll see when you have a big belly on top of your loaf. Classic case. Loaf number 3, this one's interesting. You don't see this too often. This is an underproofed loaf with a totally dense crumb. And this is fascinating because all 4 of these came from the same batch of dough. So look at the difference 45 minutes made between loaf number 2 and loaf number 3. The only difference between loaf number 2 and loaf number 3 was 45 minutes of time. I didn't handle this in any different way. So what happened here between 2 and 3 is that's where the yeast really started to run out of gas, and the loaf started to condense a little bit because the lactic acid bacteria and the protease enzyme start to deteriorate the gluten structure in the loaf. So that one's really fascinating to me that we went from these huge cavernous holes to this dense crumb on loaf number 3. And then loaf number 4, we go back to these holes, but look at the shape. The shapes of these holes, these are almost perfectly circular tunnels in here compared to these big caverns on loaf number 2. And this is because the gluten is starting to break down. In loaf number 2, the gluten was still strong, so when that yeast gave its last gasp in the oven, it's stretching really tight, strong gluten. Over here in loaf number 4, the gluten is starting to break down, so I'm not getting the stretch, but I'm still getting these air tunnels from the yeast, filling these with carbon dioxide, but the shape is quite different because I'm pushing towards overproofing this loaf in terms of the gluten deterioration, while it's underproofed in terms of the yeast aeration. This is really kind of a paradox. You don't see this very often because usually when you have a severely overproofed loaf, you would have a very dense crumb because the yeast has already spent all of its energy. This still shows some unspent energy here in loaf number 4, but the crumb was already deteriorating as the gluten was weakening, so we had no more time to go on this. We could have let this go 6.5 hours, 7 hours, and try to give that yeast a little bit more time to fill the gluten matrix, but by then the gluten matrix would be mush, it would be gone. So we just cut this off and kind of put it out of its misery after 5 hours and 45 minutes. That was only going downhill from here. So I hope you found this video to be educational. I certainly did in more ways than one. And now I am going to go eat some seriously underproofed but great tasting bread.